Hello, this is Ms. Griffin taking a look at Unit 6, Skill 5. Your essential question's kind of long, so if you need to pause the video while you write it down, please do. Otherwise, just write as you hear me talk. What's the difference between an angle of elevation / depression, yes, this is supposed to be like a backslash, / depression, and what is important to remember in real-world problems? So that's our focus today, is real-world problems. This front page, we're not actually doing any math. We're just taking a look here and seeing what types of problems you might potentially see. But this is, excuse me, this is not a complete list by any means. Sometimes we talk about a man flying a kite. Most of the time, or some of the time, he's flying it from his foot. And I know that might seem goofy, but that means that the angle comes from the ground and his foot. Like, you've never been to a beach before and put the kite string under your foot because you don't want to hold it with your hands, right? That's how all people fly kites. At least that's how cool people fly kites. Or you can be like a non-cool person and fly a kite from your hand. And so here, our triangle would actually be drawn this way, where the angle of elevation is made from the hand and a line parallel to the ground. So here we would have to adjust for some height of this person if we were to find out how tall the kite is. Because this kite would not only have this value of x for a height, but it would also have this value of h for part of its height. So the height in total of this kite would be x plus h. Sometimes we talk about these things called support cables, or a guy wire, G-U-Y, and then wire, where we have a wire or a cable supporting some tree or structure of some sort. So again, the angle of elevation is formed with the ground. Sometimes we have a boat looking up at a lighthouse, so here we could have an angle of elevation this way, but you could also have a person in the lighthouse whose angle of depression looks down at the boat. But wait a second, isn't this so cool? Because we just made a Z, and both of them are called theta because alternate interior angles are congruent when lines are parallel. Now, I've been saying angle of elevation and angle of depression, and you've seen these words before back when we did finding angles, but let's just reiterate what they mean. Angle of elevation means that you have to look up, but not only are you looking up, you are first looking out and up. Right, so you look out, you look up, and then there's your angle. Angle of depression is just the opposite. You look out and down. You don't look immediately down, you have to look out first. Look out and down, there's your angle. Angle of depression. All right, flip it over and we'll get to some questions where you might be putting your artistic skills to test. Example 1 is one of my favorites for drawing because it ends up turning out horribly, but it's fun to see what you guys can draw. A helicopter is directly over a landing pad. Okay, so we have a landing pad. And we have a helicopter. Oh boy. I don't know how to draw a helicopter. Okay, helicopter's directly over a landing pad. Billy is 110 feet from the landing pad. So here's little Billy over here. And he's 110 feet away. And he looks up to the helicopter and sees it at a 65-degree angle. Now, because they didn't tell us his height, we're going to assume he's seeing it from the ground. And I know that seems goofy, but unless they tell you a height of Billy, we assume the angle of elevation is made with the ground. So we're going to put our 65 degrees right here. And then we want to know how high the helicopter is. So its height, we're going to choose to call x, because we don't know what it is. Round to the nearest foot. Okay, so now we have a picture, nice and beautiful, where we are trying to find a side length. So again, you always circle your angle, you label your sides. Here's my right angle. So I think Wesley tells you to put the hypotenuse on here first, opposite the right angle. Then you go opposite your given angle, and that gives you O, and then the leftover piece is your adjacent, because it's next to the circled angle. So here, we don't care about the hypotenuse at all, actually, because it's doesn't have an expression on it or a number, but we do care about O and A. So if you think back to SOHCAHTOA, So TOA. O and A force us to use tangent. So we're going to write out our expression, our equation, and then actually solve it. Tangent of the angle, 65 degrees, is equal to the opposite side over the adjacent side. Because there's a proportion on the right-hand side and x is part of the proportion, we're going to put this over 1. So then that way we can just cross multiply. X times 1 is 1, and then we have 110 times tangent of 65. I need you to type that in your calculator, 110 times tan of 65. So we end up with x equals 235.8958. But it does say to round to the nearest foot, which means that there are no decimals, so we take the 5 and look to the right. The 8 is telling the 5 to bump up, so our final answer here should be x equals 236. When you're ready, start reading example 2 and trying to draw a picture. A piece of lumber leans against a wall. Lumber is just wood. So we have a wall, and we have a piece of lumber leaning against it. The top of this 40-foot piece of lumber, so the wood is 40 feet, touches a point on the wall, right here, that's 36 feet above the ground. So I can close this up to make my right triangle. Find, to the nearest degree, the measure of the angle that the lumber makes with the wall. So here's my lumber, here's my wall, so the angle we care about is up here. Okay, so if you don't like calling your angles as theta, you can choose to call it x. I'm not sure what Wesley did in the videos you saw prior to this, but I always use theta. You can use x. It's your choice. So here, circle your angle, label your sides, opposite, adjacent, and hypotenuse. Again, starting with the hypotenuse is across from your right angle. Opposite would be opposite of your given angle, so O is over here, and adjacent is the one next to it, the leftover. So here we have adjacent and hypotenuse, and if we think back to SOHCAHTOA, that forces us to use adjacent and hypotenuse with cosine. So cosine of theta, or x, is equal to adjacent 36 over hypotenuse 40. Now, yes, there's a fraction on the right-hand side, but we're not going to put this over 1 because our x, or our theta, is inside parentheses. So we have to take it outside, get it by itself. And so in order to do that, we're going to put cosine on the other side, but apply the inverse, that little -1. Remember, don't say cosine -1, it's cosine inverse of 36 over 40. So type that in your calculator. You get the trig functions just the same way you get the other ones, right? You go to the trig button on your calculator, cosine inverse 36 over 40. So the decimal we get is 25.8419. And it says to the nearest degree, so a whole number, take the 5, look to the 8. All the rounding is exactly the same as in the last problem. The 8 forces the 5 to go up, right? 5 and above, give it a shove. 4 below, let it go. So we have final answer of cosine equals 26 degrees. Taking a look at the next problem, we have Phoebe stands on level ground at point B. So Phoebe's over here. She's 20 meters away from the foot of the tree. The foot of the tree, or the base of the tree, is just the point at the bottom. She whips out her handy-dandy pocket clinometer and measures the angle of elevation to the top of the tree. This pocket clinometer is just a tool to measure angles. From her eye height of 1.6 meters above the ground as 32 degrees. So the angle of elevation, look out and look up, is 32 degrees. But that's coming from her eye height, which is 1.6 meters off the ground. How tall is the tree round to the nearest tenth? So in the end, we want this entire distance from R to C. Now this 1.6 that we see over here can also get carried over here from C to D. And because our right triangle is formed here, we can choose to call this piece X from R to D, because we can find that first. And then in the very end, the whole entire height, RC, is made up of x and 1.6, so we add them together. So when we're asked for how tall the tree is, it's x plus 1.6. Don't forget to add that 1.6 back in. All right, so we take our angle, we circle it, we label our opposite, adjacent, and hypotenuse. Try to do that for me without me. So like take 20 seconds to do that. Okay, that was only 10 seconds, but I think you're ready. So here this x should be your opposite, and this 20 can also get moved up and become your adjacent. O and A, if you think of SOHCAHTOA, tells us to use TOA. Opposite over adjacent. So we have tangent of our angle, 32, is equal to the opposite x over the adjacent 20. Go ahead, take a minute to solve this for x. Hit play when you're ready to see my work and see the answer for x. So I found x to be 12.49739. Now it does say that we want the entire height of the tree, so don't forget that h, the height of the tree, is equal to 12.49739 plus 1.6. So when you type that in your calculator, you end up getting something like 14.09739. However, we do have to round that because it does say to round to the nearest tenth. So nearest tenth, that's the first decimal place, look to the right. The 9 is telling us to bump the 0, so we have our height is equal to 14.1. Flip it over when you're ready to the next example problem. Okay, so in this problem here, we're looking at the top of an apartment building. The angle of depression, remember that means look out and then look down, is 38 degrees. Sorry about the bell. To a car that is parked on the street below as shown in the diagram. The car is parked 80 feet from the base of the building. So here's your car and here's your building. Find the height of the building, say x, to the nearest tenth of a foot. Now, clearly, this angle of depression from the top of the apartment building is not within our triangle. So we have to think back to what we were talking about before. If we have a z or a backward z, we can just copy the angle down below. Because, again, alternate interior angles are congruent. So now we have our picture. We have our angle. We have our opposite, adjacent, hypotenuse. So go ahead and label those. Remember, again, that opposite is across from your angle. Adjacent is next to your angle. So here we don't have a hypotenuse. We don't care about it. So we're just going to force ourselves to talk about O and A. And if you think back again to SOHCAHTOA, TOA is OA. So we have tangent of something is equal to something. Go ahead and try to fill that out. Tangent of your angle is equal to opposite over adjacent. And because we're solving where x is in the fraction, then we cross multiply. So x is equal to 80 times tangent of 38. Go ahead and type that in your calculator, please. And then round your answer and check it with mine. You should have found 62.5 once you rounded. Okay, so the last problem we have here says that we have a shed with a pent roof that needs to have some new roof beams fitted. The width of the shed is 5 meters and the height of the pent roof is 1.3 meters. And our goal is to determine the length of the roof beams to the nearest tenth. So you can see the 5 meter wide is labeled and the height of the pent roof is 1.3 meters, also labeled, but we don't have the value of the roof beam, so we're going to choose to call that x. So if I look at this problem here, I have two sides given, 5 and 1.3, but I don't have the third side. And so this is actually not a trig problem, because we don't have any given angles besides the fact that, of course, that's a right angle. And we can't ever circle the right angle because we can't solve it in that way. So when we have two sides given and we're looking for the third side, we're going to use something called the Pythagorean theorem. So off to the side, let's write down to find the third side. Of a right triangle, we use the Pythagorean theorem. Notice that I just used THM for theorem. You're allowed to do that too. And the Pythagorean theorem has a squared plus b squared equal to c squared, where a and b are legs and c is the hypotenuse. So when we take a look at this picture that we drew off to the side, we know that the hypotenuse is opposite of your right angle. Just like you've been doing in your SOHCAHTOA problems, hypotenuse is opposite of that. And then these leftover pieces must be your legs. So we go through and we label this as A, B, and then C. It doesn't matter where you put your A and your B as long as they're both the legs. So now we get to plug into the Pythagorean theorem. A squared plus b squared equals c squared. So A, we put 5, we got to square it. B was 1.3, again square it. And C we don't know, so we call it x with a squared. In your calculator, I want you to type in this left-hand side, 5 squared plus 1.3 squared. Hopefully you found 26.69, and that's still equal to x squared. And just as we've done in the past, to undo squaring, you have to square root both sides. So go ahead and again type that in your calculator. We get 5.16624. However, the directions say to round it to the nearest tenth. So take your tenths place as the 1 and look to the right. The 6 tells us to bump up. So we have x equals 5.2, meaning the roof beam needs to be 5.2 meters long. All right, let us know if you have any questions. Otherwise, get to practice and your CFU.